All right, so welcome everyone to the webinar, Storm Resilient Urban Forests, the Role of Species Selection and Maintenance Pruning. As mentioned, my name is Holly Campbell and I'll be the host for the webinar today. I'm an Extension Associate with Southern Regional Extension Forestry, working in urban forestry and wildland fire education and outreach. As part of the cooperative extension system, our office develops educational products and resources to support regional forestry and natural resource programs across the southeastern U.S. region, such as the webinar today. Our website is sref.info if you would like to learn more about what we do, and that web link is in the top right corner of the screen. So I'd like to thank the University of Georgia Cooperative Extension for co-hosting our Zoom webinar today. Our presenter today is Dr. Eric Wiseman from Virginia Tech. Before introducing Dr. Wiseman, I'm going to provide a short introduction. So today's webinar is part of a larger series entitled Understanding Urban and Community Forests, an Extension webinar series. So this series was planned by Southern Regional Extension Forestry with input from several cooperative extension, urban and community forestry experts in the Southern region. Our speaker today, Dr. Wiseman, was part of the planning committee for this webinar series. So the slide I'm showing you now includes the planning partners for the series. Their input on key topics and speakers was essential in putting this together. So the series is designed for educators, specifically cooperative extension county educators. However, each webinar in the series is also relevant to natural resource managers, other types of educators, arborists, urban foresters, and more. So regardless of your work focus, all of you are welcome to join the webinar today and any of the webinars in the series. The goal of the series, which includes 12 webinars in all, is two parts. So one, to increase extension educators' knowledge of research-based urban and community forestry information, and two, to provide educational resources that support delivery of that information to the public. Ultimately, the series aims to increase Extension's role in urban and community forestry education and outreach. We're hoping that this series will reach not only Extension personnel focused in horticulture, urban forestry, and other natural resources, but also Extension involved in areas like family and consumer sciences and other focus areas where appropriate. So this slide includes some of the other webinars in the series. For those of you who are not familiar with the cooperative extension, the Smith-Lever Act formalized extension in 1914, establishing the U.S. Department of Agriculture's partnership with land-grant universities to apply research and provide non-formal agricultural education. Congress created the extension system to address rural agricultural issues. Today, however, extension has expanded its focus to match changes in society and economics, providing research-based education in areas like family and consumer sciences, forestry and natural resources, youth education, and much more. So popular extension programs that I'm sure many of you are familiar with is 4-H and the Master Gardener program. Extension is a trusted information source in communities. And for those of you who are not part of Extension, just to know, we make great partners to disseminate information to the public. So keep us in mind on your next urban and community forestry project that includes an educational component. So though several extension educators provide urban and community forestry information to their communities, the amount of educators in this area are few. So our hope is that these webinars will increase extension educators' role in urban and community forestry education and outreach. So I'm guessing there are likely participants listening to this webinar who are unfamiliar with the importance of urban trees and forests. So I will explain a little bit about the great benefits of urban trees and forests. As you can see on this slide, they do a lot of things. They help clean our water and air. They reduce hot summer temperatures. They reduce wind speed and noise. They've even been shown to reduce crime. They provide a sense of place and connection, beauty and food, and so much more. So, and as Dr. Wiseman will share momentarily, trees will continue to provide the benefits as listed on this slide when they're properly cared for. So I'd now like to introduce our speaker, Dr. Eric Wiseman. Dr. Wiseman is an associate professor and extension specialist of urban forestry at the Department of Forest Resources and Environmental Conservation at Virginia Tech. Dr. Wiseman is also a certified arborist and a qualified tree risk assessor. Today's webinar is part one of a two-part webinar on storm resilient urban forests. At the end of the webinar today, I'll share more information on the second part of this webinar. Okay, Dr. Wiseman, are you ready?
Yes, I am.
Okay, I'm going to stop sharing my screen now and you're ready to start yours.
Okay, thank you very much for the introduction, Holly, and thank you to everyone who is joining us today for this webinar. I look forward to talking to you. As I start sharing my screen here, I wanted to acknowledge SREF and thank them again for giving me the opportunity to talk with you this afternoon. My contact information is available here on my title slide, both through email. I'm also active on Twitter as well as on the web. Our Urban Forestry Program website URL is listed there. A quick note about the format for today's webinar. I will take an intermission for some question and answer about halfway through to address any questions that might come up during the first half of the presentation. And then we'll also conclude the hour with a second set of Q&A for the second half of the presentation. I do want to acknowledge right off the bat that this is a really complex topic that I'll be talking about today, and in truth it would probably require a day-long workshop in order to address it in detail. Given that we do have limited time here together today, I will be taking a high-level view that I attempt to address core concepts and practices. So hopefully you will be able to take away some things here today that you can put to practice, or maybe urge you to explore these concepts and ideas further. So a quick rundown of my presentation this afternoon for you. First of all, what I want to look at is the how, why, and what of tree failure during storms. I'll then talk to you a little bit about the characteristics of storm resilient trees and how you go about selecting storm resilient tree species. I'll then move on to talk a little bit about pruning young trees for storm resiliency and conclude by talking about pruning mature trees for storm resiliency. I want to start out by sharing with you a little bit about the premise for this presentation. In other words, where am I coming from on this? And a few key statements that I want to share with you here. First of all is that regardless of causation, anomalous weather events are occurring more frequently and with greater severity. Extreme weather events cause stress on trees and predispose them to uprooting and breakage. These falling trees may endanger lives, damage property, and disrupt day-to-day activities. However, the likelihood of storm damage to trees can be greatly reduced through proper species selection and maintenance pruning. And these are the two key elements of my presentation today. So given the potential for harm caused by trees during storms, why not just have communities that look like this? No trees, no problems, right? Well, the issue here is, of course, we all understand, as Holly mentioned a few minutes ago, is that trees pay us back. They have a number of social benefits, economic benefits, and environmental benefits that there's a lot of research supporting the need for trees in urban areas. The key here to understand is that the appropriate response about having trees in the built environment is that we need to create storm-resilient urban forests so that we can maximize these benefits while concurrently minimizing the costs and risks associated with trees in built environments. So I want to start off here talking a little bit about how trees fail during storms. Three basic ways that we see this happening. First of all, we have uprooting of trees when roots lose anchorage in the soil. This can be particularly problematic because these types of failures can be difficult to predict because we cannot see the roots, and there are severe consequences due to the size of the entire tree falling over and its extended reach based on the height and spread of the tree. Another way that we see trees failing during storms is by stem failure. Stem failures are often associated with high winds during the growing season, and these too can have severe consequences due to the size and potential reach of the failing tree. And then finally, we have branch failures. Branch failures can occur for a number of reasons and are probably the most frequent occurrence during storms. The consequences of these types of branch failures vary based on the size of the branch, from negligible to severe. So why do trees fail during storms? There's a number of different reasons, and I'm going to get into some technical terms and concepts here that hopefully will clarify tree failure without overwhelming your comprehension, but I think that this will be helpful as we continue to talk about species selection and maintenance pruning. First of all, Trees fail when mechanical stress, which arborists often refer to as load or loading, exceeds either root anchorage or the fiber strength of the wood in the tree. Also, gravity acting on the mass of the tree parts, exerts what are known as internal loads on tree parts. And there's also external loading on tree parts. And in storm events, this can come about due to the accumulation of ice, snow, or rain clinging to leaves, branches, and fruits. And another complicating factor in storms is oftentimes they're accompanied by wind, and this wind intensifies the external loading on tree parts. And many of these storms also include some type of precipitation that increases soil moisture. And what this does is it decreases soil strength, in other words, the resistance to soil against movement, and also reduces the adhesion of roots to soil particles. Both of these allow roots to slip more easily through the soil. I have a couple of video examples that I want to share with you to demonstrate these tree failures. The first is a stem failure of a poorly tapered conifer with a heavy load of snow. The second is a deciduous tree uprooting during a severe thunderstorm that has saturated the soil. As you watch these, I would like for you to think about the characteristics of the tree, the site, and the weather that contributed to these failures. So here we see the snow accumulation on this conifer that has a poorly tapered stem with a very low live crown ratio. Eventually, the weight of the snow becomes too excessive and the wood fibers can no longer keep the tree upright. The second one is a summer severe storm event. And here you will see the tree uprooting. This uprooting is a consequence of saturated soil in combination with wind increasing drag on the crown of the tree. So what predisposes trees to failure during storms? The key concept here is that failures could likely have been prevented through species selection and maintenance practices. Keep that in mind as we review these predisposing factors. Often what will predispose trees to failure, first of all, is either defective or confined root systems. Defects can come about due to a lot of different reasons. Two of the most common ones that we encounter are girdling or circling roots, which constrict either the stem or the buttress roots of the tree, or root systems that are confined by adjacent hardscape that do not allow the root plate to adequately develop. Another feature of trees that often predisposes them to failure is weak branch unions. In this particular maple here, we see a weak branch union that had accompanying it included bark. Included bark is when you have two stems of similar diameter growing up against one another, and as they grow larger in diameter, bark becomes entrapped between the two stems, and this will often induce decay, which is the darkened area that you see right above the healthy sapwood where the break occurred. And another common factor that we see predisposing trees to failure is wood decay. Wood decay can come about for a lot of different reasons, either through natural processes or through injuries that come about due to either human activity or from previous storm damage. Decay is caused by various microorganisms, predominantly being fungi, the causal organism that we often see causing decay. So now we've given you a little bit of background about the how and what and why of tree failures. Let's now look at the nexus between these storm failures and species selection and learn a little bit about why species selection is so important. A key point here to keep in mind is that tree species are quite variable in their wood strength, their physical conformation, and their susceptibility to defect development. In this regard, all trees are not created equally, and it's up to us as caretakers of trees to understand what these variable characteristics are from species to species to species, and then make appropriate species selections. Let's break down a little bit more these three characteristics here of physical conformation, wood strength, and susceptibility to defect development. First of all, looking at wood strength. It's important to understand that wood strength is under tight genetic programming by species for both the types of wood tissues as well as the arrangement of those tissues within the tree. It's also important to understand in this regard that there's a fundamental trade-off that we find in the evolutionary strategies of trees where we see growth rate often being compromised for wood strength and vice versa. That is, trees that tend to grow very rapidly tend to have reduced levels of wood strength as well as reduced levels of decay resistance. And conversely, those that slow growing tend to have stronger wood as well as greater decay resistance. This is very important when we consider the modes that trees fail and what might be predisposing them as failure as well. When we mention physical conformation of trees, essentially what we're talking about is how the tree parts are arranged. And again, this is under tight genetic control, but it's also influenced by the growing environment that the tree is in, temperature, moisture, light, wind, as well as what types of maintenance that we do on the trees, in particular pruning. So here we're talking about things such as the architecture of the root system, the growth habit of the tree, and the orientation of branches in the crown. And the final characteristic that I want to talk about here that relates to storm failure vulnerability is the propensity of certain species to develop defects. In particular, the ones that we find often predisposing trees to failing are girdling roots, codominant leaders, and included bark. We have quite a bit of information and knowledge about which species are likely to develop these defects, and therefore we want to take precautions in possibly planting them into our urban forest. So now we'll move to talking a little bit about selecting storm resilient species. And it's important to keep in mind here that there is no perfect landscape tree. Every species has assets and liabilities, and we make compromises when we go about species selection. There are some points to consider, though, when we think about selecting storm resilient tree species, and I want to share a few of those here with you. First of all, we need to understand what are the types of extreme weather events that either occur currently in our general area or are likely to occur in the future. Keep in mind that trees are long-lived organisms, and a tree that we plant today may have a service life of several decades in our urban forest. Therefore, we don't want to be thinking about just what types of weather occur now, but also what might be occurring in the future. And there's been lots of research done on this, predicting what the types of weather events might be in the future. Also want to consider site factors that may increase exposure of tree to extreme weather events. Examples of this would include trees located in open or exposed or elevated topography. This might be on a hillside, it might be adjacent to a large body of water, or it might be in what we know as an urban canyon, that is a location between large buildings where the size of the buildings tends to either really increase or decrease wind speeds. Another point to consider are site factors that might contribute to injuries that lead to tree defects. This might be situations where you have trees located adjacent to sidewalks or building foundations or parking lots or underground utilities where ongoing maintenance might be necessary to those hardscapes, and in the process might either damage the root systems of the tree or the lower trunk of the tree. And then finally, we need to consider our capacity to provide preventive maintenance for trees. If you have very limited maintenance capabilities in your locality, then you have to think even more critically about species selection. There are some species that if they do not receive preventive maintenance through pruning, they are much more likely to develop defects that will then predispose them to failure during storms. So what are some key traits of a storm resilient tree? Again, this is not an exhaustive list, but these are some of the things that you'll commonly hear experts refer to, and also some things that I have observed through my personal observations. First of all, a key trait of a storm resilient tree would be one that roots well in either confined, compacted, or saturated soil volumes. These are commonly encountered in urban areas, particularly the confined root systems, where we see trees being situated between curbs and sidewalks, in parking lot islands, or in urban plazas. Compacted soils are a consequence of how we develop urban land, and it makes it more difficult for roots to elongate and appropriately, satisfactorily anchor into the soil. And because these soils are often high in clay texture and dense in compaction, they have a tendency to become saturated during precipitation. And as I mentioned previously, this reduces soil strength and also increases root slippage in the soil. Another key trait to consider is slow to moderate growth rate. I mentioned this earlier because there's a strong relationship, when this is a genetic property, between the growth rate and the density of the wood, which relates to the wood strength, and the decay resistance of that wood should the tree be injured, knowing that decay will weaken the wood and predispose it to failure. Another key trait is the tendency for the species to develop a dominant central leader and broad branch angles. These are both desirable physical characteristics of the tree that will prevent the tree from developing defects that might lead to failure, either a stem failure or a branch failure. Another important characteristic or trait is coarse branch texture. And what I'm talking about here is the stoutness of the branches in the crown. What we find with coarse branch textured trees is that they tend to have less surface area, and the branches tend to be more stout and are better able to tolerate accumulations of ice, snow, or rain. And then finally, related to this, are trees that have moderate densities of foliage and fruit. This has to do with not only wind sail, so in other words, the resistance of the canopy to wind loading, but also the weight that the branches and the root system and the stem of the tree will experience during a wind event or a storm event that might induce tree failure. So remember, the guiding principle is right tree, right place, right purpose. And what that means here is we have to think about this notion that we're talking about a very specific purpose here. That is creating a storm-resilient urban forest. Other contexts and other goals will require a different mindset about what will be the right tree for that place. While I'm reluctant to provide a list of tree species that are considered to be storm resilient, because these lists are always incomplete and they're often end up being ripe for debate, I thought it might be appropriate to provide some recommendations of tree species that have proven to be storm resilient in the southeastern and the mid-Atlantic United States based on my review of literature as well as some of my personal observations. So some species that should be in your urban forest for their storm resiliency include sugar maple, flowering dogwood, Japanese cedar, black gum, hophorn beam, swamp chestnut oak, shoemart oak, and bald cypress. Again, this is not intended to be an exhaustive list nor an authoritative list, and I've tried to have a nice blend of small, medium, and large maturing species so that we can be cognizant of the space constraints that we often encounter in urban environments, but also giving consideration to the needs for ornamentation as well as deciduous and evergreen species. Contrast this for a moment with species that you should think twice before planting in your urban forest. These include species such as silver maple, hackberry, Leyland cypress, tulip poplar, Callery pear, weeping willow, and basswood. These species have various growth characteristics or a predisposition to defects that make them a greater risk of failing during storm events. And therefore, there could be significant consequences to those failures, not the least of which is loss of tree canopy cover and benefit provision. So how do we go about promoting planting of storm-resilient trees? Obviously, the tree planting enterprise in any given locality involves numerous stakeholders, both in the private as well as public sector. Well, here are a couple of things that you could do. First of all, many localities will put together what is known as an approved tree species list. And in most cases, there's lots of different constraints or criteria that are leading to the selection of species for this approved species list. But if storm resiliency is an important consideration for your community, then you might consider adopting such a list. Note that these might be appropriate for tree planting in public spaces, but they can also be used to regulate tree planting on private property as well through the site plan review process that often occurs during new land development, which municipalities often have some oversight over. Another way that we can promote planting of storm resilient trees is to require a planting permit for trees in public spaces. Many localities will use a permitting process for planting street trees that are adjacent to residential properties and are in the right of way. And the intention here is to give the urban forester or the arborist or other individual who works for the locality an opportunity to review that tree selection and make sure that it's going to be the right tree in the right place. So that concludes the first half of my presentation, and I'll open up now an intermission to take a few questions from Holly, who is monitoring the chat box and the Q&A window.
Hey everyone. Yeah, if you could please write any questions that you have for Dr. Wiseman in the Q&A, that would be helpful. So I only have to look in one place. So we do have one question here. Regarding recent research and findings of Dr. Duncan Slater about natural braces and their effect on WBUs, has there in the U.S. been a discussion initiative to alter current pruning practice regarding touching branch with branch stem over WBU in order to reduce the risk of WBU failure? You may want to explain what WBU is.
I assume that that is referring to weak branch unions, and I think that what is being referred to here is the situation where when branches naturally cross and make contact, that there's a tendency for them to either graft or to self-support one another, and to what extent that that might reduce the risk of branch breakage. It's a novel concept. It's not one that I'm aware personally of any research being conducted in the United States on it. In the United States, and I'll mention this in a little while, our pruning practices are dictated by the ANSI A300 standard and the associated ISA BMP. And certainly part of our maintenance pruning practices as well as structural pruning practices is often to go after crossing and rubbing branches in order to promote branch spacing. To what extent that might be to the detriment of taking advantage of this natural bracing that occurs, I can't really see, but it's certainly an exciting opportunity to investigate how trees might naturally brace themselves.
Okay. Again, everybody, if you have questions for Dr. Wiseman, please enter them in the Q&A, not the text box, or the chat box, sorry. Okay, we do have one from the chat box that I'll read. It says, how about the planting of trees near street lights where the tree is blocking the light? That should be addressed as well as it is required in some zoning requirements for parking lots. Any suggestions for parking lot trees?
Yeah, great question. And of course, the underlying assumption here is anytime that we're discussing tree selection, we have to be cognizant of all of the potential risks and liabilities and conflicts that go along with them. In talking about these key characteristics of trees for storm resiliency, I'm talking about a very narrow context here of thinking strictly about the development of the tree and the propensity to develop defects that might contribute to failure. But absolutely, we have to be cognizant of the space that we're putting the tree into and what the consequences might be that go beyond the wind firmness or the storm resiliency of the tree. There's lots of great resources out there on the web through various cooperative extension agencies and other organizations that talk about species selection for specific site situations such as street plantings, parking lot plantings, and so forth. I recommend that you check some of those out, and if you would like to email me, I would be happy to direct you towards some of those that I already know about.
Okay. Would you like to answer a few more questions?
I have on my schedule to go for about one more minute, so yeah.
Okay. Well, we had one participant ask if you could provide a more extensive list of storm resilient trees, maybe just because we might have participants from all over the country. Where are some good sort of Google searches people could do to locate trees for their area?
Yeah, I'm actually going to mention some resources in just a little while, so if you'll bear with me when I come to a subsequent slide, I'll point those out and I'll discuss how you might either use those resources or look elsewhere.
Okay, great. Well, we can work to answer the rest of these questions towards the end.
Sure. Okay. All right, so that concludes the first half of my presentation, where we've been focusing on the how, what, and why of tree storm failures, as well as species selection. I now want to spend the rest of our time talking about pruning of young trees, as well as mature trees to improve their storm resiliency. So we'll start with pruning young trees, and many people on the webinar today are probably familiar with the late Dr. Alex Shigo and the wealth of knowledge that he brought to us about tree biology, as well as his philosophies on arboriculture. This is one of my favorite quotes of Dr. Shigo, and it's very, very appropriate for this discussion of pruning, because pruning is one of those things that is done often with the best of intentions, but ends up having the worst of consequences, either because we don't understand tree biology or we don't understand proper arboricultural practice. So Dr. Shigo said, pruning is one of the best things an arborist can do for a tree, but it's also one of the worst things we can do to a tree. So looking in particular at young trees, why is pruning trees when they are young so desirable and effective when it comes to storm resiliency? Well, there's a few reasons for this, and this again is not an exhaustive list, but some of the ones that come to mind for me. First and foremost is that when these trees are young, we can make a lot of headway on preventing many of the defects that we commonly see predisposing trees to failure. In particular, codominant leaders, included bark, and weak branch unions. Another reason that we like to focus on young tree pruning is because it allows us more control over branch spacing and orientation. There's a couple different reasons for this. Probably the biggest is that the amount of live tissue that we can remove from a young tree is, we have much more latitude with that than we do with older trees that are less tolerant of branch removal. Also, the impact of removing any particular errant branch on a young tree is going to be less impactful on the aesthetics as well as the overall conformation of the tree when it's young, because the trees are growing quickly and they will adapt their crown conformation very quickly as a result. Another reason is because we typically see better wound response and stress tolerance. Young trees typically to have a high dynamic to static mass ratio. What that means is they have lots of energy capturing tissues relative to the amount of energy requiring tissues. So they're very resilient in that regard. They do a really good job at wound closure, forming callus as well as branch protection zones that limit the impact of branch removal cuts. And they tolerate the stress of having lost leaf area much better and recover more quickly. Another reason is that young tree pruning requires basic pruning tools and techniques. And I don't say that to imply that pruning techniques for young trees are basic or simple. In fact, I would contend that they are as complex, if not more complex, than some of the practices and procedures involved in mature tree pruning. The point here is that because you're dealing with a smaller tree, you can usually use smaller pruning tools and you can keep your feet on the ground. That is, you can access the branches with pole saws and pole pruners to do an adequate job of your structural pruning. And for that reason, this is a much more straightforward endeavor than dealing with mature tree pruning that may require either an aerial lift or climbing or incorporate chainsaws because you're presumably making larger pruning cuts. And then the last point that I'll make is that because the trees are smaller and the tree parts that you're removing are smaller, that there's going to be less debris to clean up. And this isn't particularly an important reason for focusing on young trees per se, but it is a desirable consequence in that it makes these types of pruning operations more feasible, particularly when you have volunteer tree stewards or similar groups involved and you need to gather and dispose of debris that results from the pruning work. So we saw a quote earlier from Dr. Alex Shago. Here's a quote from Dr. Eric Wiseman that relates to young tree pruning. Trees are like children. Give them proper guidance when they are young, and they won't cause you problems later on. This is an important philosophy that I like to share with people in trying to create a rationalization for why we want to focus on young tree pruning. Again, as I mentioned earlier, many tree failures are associated with defects that developed in the tree when it was young, at a time when we could have probably intervened and either minimized or eliminated that defect entirely and not have to deal with it as the tree grows older. So what are our goals for young tree pruning? I list these more or less in what I view to be the order of priority. First of all is to establish a dominant central leader. That is one leader from the ground level up through the terminus of the crown of the tree. Now, I understand that certain species have more or less of a tendency to develop a dominant central leader, and that having a dominant central leader may not be appropriate for every species, particularly ornamentals or small maturing species. However, if we're talking about large maturing trees, street trees, shade trees, typically we will want them to have a dominant central leader, because when they develop codominant leaders, it often results in imperfections in the structure of the tree that predispose them to stem failures. Another goal or point of focus would be to eliminate branches with narrow attachment angles and included bark. We saw examples earlier of branch failures and stem failures associated with included bark. What we find is that when the attachment angle of the branch, in other words, the angle between the branch and the parent trunk on the upper side is very narrow, that this predisposes that branch as it gets larger and the parent stem gets larger to developing bark that is trapped between the two that will often incite either decay or cracking that will then weaken the branch attachment. Another goal is to regulate the growth rate of temporary scaffold branches. With parking lot trees, street trees, and many park trees, we intend to eventually have a permanent base canopy height of about anywhere from 8 to 14 feet. In other words, where is the attachment of the first primary branch above ground level? We are headed in that direction because we want to provide adequate clearance for pedestrians, vehicles, and more or less keep people out of park trees by climbing them. If we want those permanent branches to have robust attachments, we need to tend to the temporary branches that will eventually come out of the tree as we progressively elevate the base crown height of the tree. So by using a technique called subordination, which controls the growth rate of those low branches, we can subsequently remove them later on in the tree's life in a way that will cause a small wound as well as cause minimal stress to the tree due to the amount of leaf area that we're removing. Next, we want to think about proper spacing of the scaffold branches. That is the primary branches coming off of the trunk that create the framework of the crown of the tree. Looking at properly spacing them both around the trunk as well as along the trunk. Having branches that are crowded, that is having their attachments in close proximity, will often weaken those branch attachments and predispose those individual branches to failure. And then finally, maintaining a suitable live crown ratio. The live crown ratio is the proportion of the overall tree height that is occupied by crown. So the tree that you're looking at in the illustration there has a live crown ratio of about 50 to 60%. The reason that's important to have a suitable live crown ratio, one that is greater than 50%, is that those lower branches will contribute to lower stem taper, and they will also serve to mitigate the bending and swaying stress associated with wind. They are force dissipators. So in the illustration here, I show a excurrent tree. This is a nice illustration done by Ed Gilman in his book, Structural Pruning. And the after the pruning illustrates what types of branches are being gone after, either entire branch removals or reduction cuts that remove portions of branches to accomplish the goals that I have mentioned here: promoting a dominant central leader, eliminating branches with narrow attachment angles and included bark, regulating the growth rate of temporary scaffold branches, ensuring appropriate spacing of scaffold branches, and maintaining a suitable live crown ratio. So this is an example of an X-current shade tree. They tend to be better behaved, particularly in the characteristic of developing a dominant central leader, but we often plant in our urban forest species that have more of a decurrent shape. That is a tendency to develop multiple leaders. And I would contend, and most experts would contend, that while this might be a desirable mature form that the tree might eventually develop into, while the tree is young, we still want to promote a dominant central leader so that we don't get crowding close to the ground of numerous branches that are likely to develop weak unions and might eventually fail in a storm event. If you're interested in learning more about structural pruning, I encourage you to check out Dr. Ed Gilman and co-author's book entitled Structural Pruning, A Guide for the Green Industry. Wonderful, wonderful illustrations in there, as well as photographs, as well as step-by-step instructions on how to go about doing structural pruning of not just young trees, but also intermediate age trees and mature trees. So let's move on now and talk a little bit about pruning mature trees for storm resiliency. As trees transition from youth to maturity, typically we want our pruning to focus to shift from structural development to looking at load mitigation. In other words, selective removal of tree parts in order to minimize the amount of load or stress from either internal gravity loading or external precipitation and wind loading in order to minimize the risk of either branch, stem, or root system failures. So what are our goals for mature tree pruning? Understanding that we are tending to focus on load mitigation. First of all, we want to understand that the energy dynamics and the vitality of mature trees is very different than young trees. In mature trees, the ratio of energy generating or capturing mass to energy requiring mass is shifted considerably. The vitality of these trees has diminished, and they cannot tolerate as well the removal of live branches. They can also have, because they have lower vitality, they tend to be slower in sealing wounds, and they tend to be less able to develop well-fortified branch protection zones in the interior of the tree. So for this reason, I just want to point out that we need to be very precautious in any live tissue pruning that aims to reduce loading and to improve storm resiliency. However, live tissue pruning is often required, and what we're trying to do there first and foremost is to reduce loading on any defective tree parts in the tree. Now, understanding, granted, that oftentimes the better thing to do is to completely eliminate the defective tree part, but that might not be a possibility. It might not be a possibility because the defect is in the stem or the root system and thereby would require entire removal of the tree, or the defect might be in a branch that is so large that to remove it would disfigure the tree or extraneously stress the tree and perhaps lead to stress and decline of the tree. So when possible, completely remove defective parts, but in some situations it might be appropriate to use selective pruning of the lateral branches on that defective part in order to reduce the weight upon that particular branch and the wind sail that it might experience. Another goal with this load mitigation is to reduce what is known as the bending moment on tall stems and overextended branches. The bending moment refers to the force that is exerted on a basal portion of a leader or a branch or the trunk due to the dissipation or the movement of force from the extremity of that branch or the height of the tree down through that tree part, acting kind of like a lever. That is, if you think about the length of a lever, the longer the lever is, the more force you can exert at the fulcrum. What we are trying to do with reduction pruning to reduce the bending moment is to shorten that lever arm and thereby reduce the amount of force that is experienced at the fulcrum, either being the branch attachment, the lower stem, or at the root collar where the buttress roots are located. Fourth, reducing wind drag on dense canopy. As I'll show you in a moment, there are techniques for reducing the density of live branches. In some cases, this might be appropriate for certain species in certain circumstances to open up the profile of the tree and thereby allow the wind to move more cleanly through the tree and reduce the amount of wind drag exerted upon the tree and thereby the force that is exerted upon the branch attachments and the trunk and the root system. And then finally, a goal for mature tree pruning related to load mitigation would be the removal of either load or drag-inducing vines and epiphytic plants in trees. There's a whole host of invasive vines, that are likely to climb into trees. Some common examples that we encounter are bittersweet and English ivy. These do a couple of different things. One is that they add mass to the tree parts. The other thing is that they make the canopy more dense and increase the wind drag. The same thing could be said for certain types of epiphytic plants, such as Spanish moss or ball moss. They can also add considerable load or increase the drag that is experienced in the canopy of the tree. This is an interesting photo, and I wanted to talk about it just for a moment here. This is a tree that's on the Virginia Tech campus. It is a bur oak, Quercus macrocarpa, that is named the Allwood oak. It is named for William Preston Allwood, who was a horticulture professor at Virginia Tech in the late 1800s. And this tree was named for him for two reasons. One was because he made such a substantial impact on the horticulture industry in Virginia, but also because he planted this tree sometime around 1895. And this was discovered by an amateur biographer here at Virginia Tech who was looking through some of Dr. Allwood's records. What you see here in this photograph is a service day that was carried out several years ago by some arborists in the Mid-Atlantic chapter of the International Society of Arboriculture. There were 5 different arborists who were involved in various arboricultural treatments in the tree. There was load mitigation pruning being done, as well as installation of some support cables, as well as a lightning protection system. Those are 2 additional practices that we won't talk about today, but have a connection to storm damage to trees. That is, support cables are often used in addition to or as an alternative to pruning in order to fortify or reinforce weak tree parts, primarily branches. And then lightning protection systems are intended to dissipate or minimize the injury caused to trees by a lightning strike. The pruning prescription on this tree and this particular project was focusing primarily on very minimal live tissue pruning and very specific pruning on very specific branches in order to minimize both loading as well as to reduce bending moments, because there are quite a few large branches in this tree that have less than desirable branch attachments on the main trunk. And then finally, taking a quick look at some tree pruning methods for mature trees. One of the most common methods that we would use for load mitigation would be what is known as crown thinning. And as this illustration shows here, this involves selective removal of interior branches to decrease the density of live branches in the tree and thereby not only reduce the amount of weight, but more importantly, reduce the wind drag. That is, allowing the wind to move more effectively through the crown of the tree and thereby reduce the amount of force or stress that the tree experiences in a wind event. Another common pruning prescription would be crown reduction. Crown reduction, as the name implies, is intended to reduce either the height and or the spread of the crown of the tree. And what this is particularly going after is trying to reduce the bending moment, that is shortening the lever arm, of either individual branches from the side or reducing the bending moment of the height of the tree by making the tree shorter. It's a little hard to tell in the graphic here, but in the middle frame you will see the outline in gray of the previous stature of the tree relative to the tree after pruning. And the reason this is important to note is that there are very strict limits on how much live tissue that we can remove from trees. The ANSI standard that I'll look at in just a moment points out that this should not exceed 25% of the live tissue. And I would contend that with mature trees and veteran trees, we want to be even more conservative than that, perhaps not going beyond more than 10 to 15% live tissue removal. So the consequence of this is that you can't make an appreciable difference in the size of a mature tree through reduction pruning that's done in compliance with ANSI A300 standards. Related to this is we do not top trees to make them more storm resilient. In fact, doing so will increase their long-term storm damage risk. And the reason for this is twofold. One is that these heading or internodal cuts that are made through the stems are very difficult for the tree to deal with through compartmentalization of decay. And as this cutaway shows, above the person's thumb there is where a heading cut was made in a topping operation. There has been extensive decay in the stem that was present at the time of topping. And then also this topping induced sprouting. So in the upper left corner of the photo is the base of several sprouts that resulted from the topping in response to the topping. These tended to have very, very vigorous growth rates, and they tend to be weakly attached. They tend to develop inclusions, as you can see there. In other words, bark entrapped between adjacent sprouts, and they tend to not have much sound wood to be attached to on the basal portion of the stem that was cut. So how do we promote proper pruning? First and foremost is to encourage the use of the ANSI A300 standards and BMPs. I do want to point out, understanding that we may have an international audience today, that pruning standards differ from country to country. The ANSI A300 is the one that is appropriate in the United States. And the ISA's BMP, the smaller booklet there, it essentially takes those standards and it interprets those for a field application. And then the final point here is to ensure that you employ a qualified arborist. Risk reduction pruning in particular requires a great deal of discretion and skill, and it can actually make things worse for a tree if improper crown reduction or improper thinning is done. So be very careful in selecting a qualified arborist to do storm risk reduction pruning. I mentioned earlier some suggested readings. These are 3. In each one of these, you will find some more extensive lists for trees that are known to or thought to be more storm resilient. Each one of these publications is associated with a university. The one on the left is associated or was written by Dr. Rich Hauer, who is currently a professor at University of Wisconsin-Stevens Point. The middle one there, and it looks like that my graphics didn't work out very well here. This is taken from the University of Florida. And then the one on the right is a Purdue University publication. I apologize for the graphics not displaying correctly here. If you want me to send you the citation for those 2 publications, I'll be happy to do that. So that brings me to the conclusion of my presentation. We have about 6 minutes for some question and answer. I appreciate your time and attention today. For those of you who will be moving on, I encourage you to think about these concepts and practices I've shared with you, and hopefully you'll find an opportunity to extend this knowledge to your clientele and maybe collaborate with your local community to try to get some of these practices incorporated into public tree plantings. So thank you very much for your attention.
So Eric, if you can stop sharing your screen, I'll start sharing mine so we can continue. All right, give us just a second here. Okay, let me get to my last slide. All right. So thank you so much, Dr. Wiseman, for that excellent overview on tree selection and pruning guidelines considering potential storm stress or damage. So you guys, please type in the Q&A box. We'll try to get to a couple of questions. I see there's a lot piling up, so we probably won't get to all of them by the end of the hour. But I wanted to use the remaining minutes now while you're typing in the Q&A box to go over this last slide that all of you can see. And let's see, so as mentioned, this is a two-part webinar. Dr. Richard Hauer, who Eric just mentioned a resource from, is going to be doing the second part of this webinar. And his webinar is Storm Resilient Urban Forest Response Resilience, Are You Prepared to Respond? So he's sort of looking at during the storm and then immediately after a storm, how to react and work with trees at that time. So if you want more information about that particular webinar on May 23rd, you can go to forestrywebinars.net. It is listed there. If you have any questions about the webinar, please email me at hollycam@uga.edu. If you want to learn more about the entire series that this webinar is part of, you can go to sref.info and you'll see a link there for the Urban and Community Forestry webinar series. All of the webinars, I saw several questions in the chat box. This webinar will be recorded, or it is being recorded. It will be archived, and it will be listed as on demand at forestrywebinars.net. So if you want credits, so we offer a short satisfaction survey. We'd love if you could fill that out, or if you have elected to receive. We're only offering ISA and SAF credits, and I think we also may have Georgia logger credits. I have to look back at the site. I apologize, I don't remember the exact name for that. But we don't offer what I think someone had asked about LA credits. I'm assuming that's landscape architecture. We did not sign up for LAR credits. Apologies for that. But in order to answer that survey or to receive your credits, you need to return to the open browser window that you had and go through step 2 on forestrywebinars.net. Okay, let me open up the Q&A and we'll see if we can answer just a few questions here. All right. Okay, is there a longer training available on this topic, Dr. Wiseman? Specifically, the participants interested in some training that offered species-specific concerns and benefits related to selection, planting, and construction tolerance.
Yeah. Great question. I don't know right off the top of my head anything that might be coming up. Of course, it would be excellent to follow up and watch Dr. Hauer's second part of this webinar on May 23rd, where he'll be talking more about preparation for storm response, and he may also get into more of the planning type things. I would further encourage you to get in touch with either your state urban and community forestry coordinator or state urban and community forestry council, or reach out to your Virginia cooperative your state cooperative extension and inquire about any types of programming, or perhaps with your local or regional chapter of the ISA.
Great. Okay, so let's see what time we've got here.
And I'm willing to hang on for a minute, Holly, if you are and others are as well. If you can move on, that's fine. I did see one comment that someone had about designing appropriate soil volumes to minimize risk of tree failures. It's interesting. I didn't want to get too much into site design, but it's absolutely a critical consideration. I did some research a few years ago in cooperation with the Bartlett Tree Research Lab, looking at various types of engineered versus conventional soil volumes. And we can use either a suspended pavement or engineered soils such as the structural soil or the root silva cells to increase rooting volume and therefore increase the anchorage of trees, and in that way be able to lessen the risk of tree failures due to root slippage or root system failure. So good comment.
Okay, let's see what else we have here. Are there instances where reducing wind drag or thinning reduces the natural dampening effect of a full crown? And can reduction pruning also reduce long-term flare and girth and formation of those large lateral limbs?
Yeah, great questions. And of course, the ISA has been very active in supporting tree biomechanics research over the last few years. I don't specialize in that area, but I do keep a close eye on the research that's coming out. I guess the short answer is that I don't know, and those are hypotheses that absolutely need to be evaluated through controlled studies. The whole topic of tree biomechanics is a very complex topic, and it's one that's very difficult to study under controlled conditions. And I know that the ISA is very engaged in that process and is continuing to support biomechanics research. So hopefully some of those questions will get answered in the future.
Okay, I think we should probably go ahead and wrap up now. And I hope that's okay with you, Dr. Wiseman.
That's fine.
Just to keep with time here. I've seen a couple of people post that they're having trouble going on to step 2. I'm not sure what the problem is there. And I need to reach out to our portal manager to try to figure that out. So if you could put your name and email address in the chat box, I will maybe stay logged on and I'll try to address that with you through email, okay? Okay, all right. Well, thanks so much, everyone, for joining the webinar. And thanks again, Dr. Wiseman, for presenting on this really important topic. We really appreciate it.
I was very glad to do it. And if you would like to send me the questions, Holly, I will attend to them as my time permits.
Okay. Okay, that would be great. And also we had a request to have the names of the resources and maybe web links that you had mentioned in your last few slides, so we can send that out with answers to some of the questions as well. I also wanted to mention, if everyone, we talked about Dr. Hauer's webinar coming up on May 23rd, but we also have another webinar in this series from now until Dr. Hauer's webinar, which is on May 9th, and it's entitled 27 Years of Extension Urban Forestry Outreach, a Pennsylvania Success Story. So that's being presented by Vincent Catrone, who's a Regional Extension Urban Forester at Penn State University. So thanks again, everyone, and hope everyone has a great day.